Over the years, centuries, and millennia, we have been watching the moon and wondering, where did it come from? What is it made of? And what events created the distinctive pattern of light and dark on its surface? To find out, we've sent satellites out to crash onto its surface. Astronauts to comb its craters and hillsides and collect rocks. And high-tech spacecraft to map its nooks and crannies. A half-century of study has brought us closer to the answers. Many scientists now believe that the moon was born in a monumental collision between Earth and a Mars-sized body early in the history of the solar system, some 4.5 billion years ago. From the remains of the impact, a giant ball of magma coalesced in Earth orbit. Gravity sculpted this hot mass into a sphere. In time, its surface cooled, forming a hard crust with magma just underneath. Around 4.3 billion years ago, a giant impact battered the moon's south pole, sending debris as far as the opposite side of the moon. The impact formed the Aitken Basin. At roughly 2,500 kilometers in diameter and 13 kilometers deep, it is one of the largest known impact craters in the solar system. Its formation marked the beginning of a period of large-scale changes to the moon's surface. Over several 100 million years, the lunar terrain was rocked by a succession of heavy impacts. Some formed large basins that would eventually fill in to become the dark-colored patches of the moon known as maria. These impacts punched enormous holes in the relatively thin lunar crust. Because the moon had not yet fully cooled on the inside, lava began to seep out through cracks opened up by the impacts. Lava spread throughout the craters, gradually filling them in and cooling. Because of the high iron content of this lava, the mare regions reflect less light and therefore appear darker than the surrounding highlands. Around 1 billion years ago, volcanic activity ended on the near side of the moon as the last of the large impacts made their mark on the surface. The impacts did not cease, although they were much smaller than the ones that formed the largest basins. Some of the largest and best-known impacts from this period formed the Tycho, Copernicus, and Aristarchus craters. They feature distinctive rays that stretch out from the crater sites, formed by the material blasted out at the moment of impact. Finally, after billions of years of relative quiet, we arrive at the moon we see today. Though its surface continues to be affected by impacts, the bombardment has slowed dramatically. The features we now see on the moon's surface are a permanent record of its early history. Within them, too, we are finding clues to the evolution of Earth itself.